Hello students, today we will study the theorem number 7.2. This is the topic of standard 9 chapter number 7 triangles. So now we are studying whatever the concept is related to only one triangle. Till now we have studied whatever that is related to the two triangles, that we are proving the two triangles congruent, right? So this is about the properties of a triangle. So for a single triangle, if there is only one triangle, then which kind of properties it can hold, that we have to study. So regarding that, one of the theorem we have given in the form of theorem number 7.2. And what is the theorem? Theorem is angle opposite to equal sides of an isosceles triangles are equal. So we have given that one of the a triangle that is of the type isosceles triangles. We know that the triangles are of many types: equilateral triangle, isosceles triangle, scalene triangle, right angle triangle. Out of that, this theorem is regarding to the isosceles triangles. So if there is a isosceles triangles, then the angles opposite to the equal sides will become equal, right? That means if here we have given that side AB and AC of triangle ABC are equal, then the opposite sides, that means the opposite side of this, the opposite angle of this AB side is angle C, and the opposite angle of this side AC is angle B. That means B and C must be equal, right? So what we have to prove here is that angle B is equal to angle C. This thing we have to prove, right? Okay, so let us consider this one of the triangle ABC is an isosceles triangle. Let us draw AD. What is AD? AD is angle bisector. AD is angle bisector of angle A, right? What will happen if there is an angle bisector? That means this total angle BAC is divided into the two parts. One is BAD, that means this much of the angle, and second one is CAD, that means this much of the angles. So this total angle is divided into the two equal parts, right? Okay, now consider here, if we want to prove that B and C are equal, how we can prove this? Obviously using the congruent of the two triangles. So let us consider the two triangle ADC and ADB. So here we have to consider two triangle, triangle ADB and triangle AD and C, right? Okay, here we have given that AB side and AC sides are equal because it is an isosceles triangle. So one condition we can write down that AB is equals to AC. What is the reason? Equal sides, right? These are the equal sides. One more thing we can write down, that is about the angle, because AD is the angle bisector. So angle BAD will become equal to angle CAD, right? Two conditions we have written down. Now think about the third condition. Yes, AD, because AD is common, AD. So AD is equals to AD. This is the common side, right? Okay. For this, we have the reason that AD is the bisector of angle A. So there must be reason for each thing, each condition you write down here, right? So now, according to these three conditions, we can say that this triangle ADB is congruent to triangle ADC. Right? By which criteria we can write down this? See, consider one of the triangle. Suppose we are considering triangle ADB. So in that, one is the side, this is the angle, and this is the another side. So this is the criteria. We can say that the side angle side. So by side angle side criteria, we can say that these two triangles are similar. Okay, if the two triangles are similar, the corresponding parts are also equal. So if we take the angle BABD, right? If we take the angle ABD of this triangle, then we have to consider ACD, angle ACD. these two triangles, these two angles will become equal according to the CPCT. Right? Now, what is this? ABD. ABD. That means angle B. And what is ACD? ACD means angle C. So see, we can now write down that angle B will become equal to angle C. So this is the proof. If we have given the two sides of an triangles are equal, then their opposite angles will also become equal. So this is theorem number 7.2. Now can we think about the opposite of this? That means if the two angles of an triangles are equal, then their opposite sides will also become equal. Yes, that is right, and it is given as in theorem number 7.3. See, the sides opposite to the equal angles of a triangle are equal. That means if we have given, see here this is we have to prove, and what is given? We have given that AB and AC are equal. Here we have given, what we have given? Here we have given that the angles are equal. Let's suppose angle B and angle C are equal. Then we can say that their opposite sides. That means if we consider angle B, then its opposite side is AC. AC will become equal to opposite side of angle C, that is AB. Right? So these two theorems are opposite to each other. Right? Okay, so we can also say the converse of each other. So this theorem is the sides opposite to the equal angles of a triangle are equal. Right? So now based on these two theorems, let us solve one of the example, that is example number 6. So what is the question? Question is, in an isosceles triangle ABC with AB is equals to AC, D and E are points on BC such that BE is equals to CD, so that AD is equals to AE. So see, here we have given that ABC triangle, this triangle is an isosceles triangle, but which two sides are equal? AB and AC sides are equal. One more thing we have given is that two points are then on the side BC, one point is D, another one is E. So when we join this A with D and A with E, we get the two more lines on this side BC. Now one more thing we have given is that BE portion, that means B to E is equals to C to D. And what we have to prove, that AD side is equals to AE side. Okay, so let us solve it. Now how we can prove that AD and AE are equal? First question arise in our mind is that how we can prove that AD and AE are equal. This we can prove only by making the two triangles congruent. So in which triangle this side AD is there? See, AD is there in many triangles, because how many triangles are there? Consider, there is one triangle is ABC, the main triangle, then one triangle is ABD, one is ADE, one is AEC, one is ADC, and one is ABE. So many triangles are there. So which triangle we have to consider? See, we have to consider the two triangles in which the side AD and AE are there. So AD is there in this triangle ABD, also it is there in triangle ADC. So out of that, now which triangle we have to consider? Let us first of all focus on what we have given. We have given that AB side and AC sides are equal. If we consider triangle ABD, then we can take this side as one of the condition, right? If we consider triangle ABD and ACE, if we consider these two triangles, then our sides AD and AE are also there, and AB and AC are also there. So we can take one of the condition to prove that two triangle congruent. So in this way you have to think that on which triangle you have to work, right? So let us first of all write down that AB is equals to AC. Here we have given that AB is equals to AC. So if the two sides are equal, then their opposite angles are also equal, that we have studied here, right? That angles opposite to the equal sides of an isosceles triangle are equal. So the angle opposite to this side AB is angle C, right? Angle C. And angle opposite to side AC is angle B. This we can write down according to the theorem 7.2. Theorem number 7.2. Now see, we can take this angle C as angle ACE. Angle ACE. Okay, we can take this angle B as angle ABD. Angle ABD. Right? Okay, now give it the equation number 1. This is give it equation number 2. Now, where we are? We are at which true triangle we have to consider. Now focus on this thing that AB and AC are equal, angle ABD and angle ACE are also equal. Now which side is remain? AD and AE, that we have to prove. So AD is here, AE is here. So obviously we have now considered triangle ABD and AC, right? So this is how we can decide to take these which two triangles we have to take. Now consider the two triangles, triangle ABD and triangle ACE. See, out of this two conditions we already have, that is AB side is equals to AC side. This we have take from 1, or from we can take it from the given. Second thing, that is we have write down here is that angle ACE is equals to angle ABD. This we have taken from 2, right? Now what is the third condition we can take here? See, one more thing we have given is that BE is equals to CD. BE is equals to CD. But this is not the part, the side of the triangle. But not BE is the part, but BD is the part of triangle ABD. In the same way, not CD is the part of the triangle ACE, but CE is the part of triangle AC. So if we subtract this DE from both the sides, then we can get the required result. So let us subtract DE from both the sides. So BE minus DE is equals to CD minus DE. Now see, what is BE minus DE? BE minus DE. So what will remain? BD will remain. BD is remain. Okay. Now CD. CD minus DE. What is remain? CE. CE. So this will be our third condition. Now see, both these triangles we can write down are congruent. Triangle ABD is congruent to triangle ACE. ACE. Right? Now which criteria is there? One of the side is there, this angle and this side. That means side angle side. So we can write down it by side angle side rule or side angle side criteria. Now as the two triangles are congruent that we want to prove, now according to the CPCT we can write down side AD is equals to AE. Side AD is equals to side AE. So this is the required result. Okay, so see here we are using the concept of this theorem number 7.2, that is the angle opposite to the equal sides of an isosceles triangles are equal. Okay, so this is all about this lecture. Thank you.